everyone, welcome back. My name is Roland with Game of Apps, and tonight we're going to be doing another critique, a code critique of the coding challenge for week 6. And tonight I have with me here Ronald. Hello, Ronald.
Another great week of submissions. We saw a couple different approaches to the problem, but I'm looking forward to get it into the meat and potatoes of things and have a discussion about what you guys did.
Okay, awesome. Thank you, Ronald. So, without further ado, I guess let's jump into it. So, Ronald, I guess you can introduce the problem for this week.
Yeah. So this week's problem is the house robber, which is we have a robber that wants to optimize the houses he or she needs to rob, but there's a catch. If he tries to rob 2 adjacent houses, the police will be alerted, and therefore he will be busted. So what he needs to do is pick houses that are not adjacent, but also to maximize the loot he can get. And the other wrinkle in this problem is that the houses are in a circle. So he cannot rob both the first and the last house in the list. The problem was presented with an input which was an array. So the first and last element of the array are actually connected together and considered to be adjacent houses. So for the first example here, we have the homes with the loot values 1, 2, 3, 4, 5, 6. So in this example, it's very clear that we should rob house 2, 4, and 6 for the maximum value of 12. In the second example, we have both 6, 2, and 5 for houses 1, 2, and 3. Now, if you tried to rob both house 1 and 3, then you will get busted. And if you try to rob house 2, then you're only going to get the profit of 2. So the answer for the second example is 6, because you can't rob house 3. And in the last example, we have one case where both house 2 and house 5 are actually the max values. So if you employed the strategy where you simply skip a house every time without considering the other values that might be farther along, then you're actually going to be missing out on loot. So for the third example, the max loot you can get is 20. And that's if you employed the more smart strategy of looking ahead to see what the total value you can get from all the houses are while still staying in the rules.
So there were a couple submissions that employed this strategy. For lack of a better name, I'm calling it the even-odd strategy. So what they would do is they would go through the array and look at all the odd houses. So in this case, the first, third, fifth, and seventh house, right? And look at what that total is. And then they would go and look at the alternate homes, the second, fourth, so the even homes. And then look at what that total is. Now, this works nicely if you have an even number of homes. But if you had an odd number of homes, then they have 3 scenarios they have to look at. So yeah, so you'll see there's 3 iterations, 3 scenarios on the right side. The top one shows all the even houses, and then the middle one shows all the odd houses. But you can't pick the last one because, again, like Ronald said, the last one and the first one are adjacent. So then for the odd case, we have 2 scenarios. One where you have all the odd ones except the last one. And then the third case was where you have all the odd ones except for the first one. The problem with this scenario is that it does not take into account that last example that Ronald talked about, where instead of going every other house, the optimal solution actually is to jump 2 houses. So 10, jump 2 houses, and then another 10. So in this scenario here, the maximum loot is 20. This strategy does not give that result, right? It would take 10, and then it'll take the second 2, and then it misses the next 10. So there were a number of people who submitted this, and we're not showing your code in this critique because it misses this scenario. So this submission here was submitted by Oscar. And before we jump into his code, let me just walk you through his strategy here. So what he does is he takes two approaches. So first he takes a look at all the houses except for the first one, and then the second approach is all the houses except for the last one. So he splits the logic into two. Then he figures out the maximum loot for the first scenario without the first house, and then the maximum scenario without the last house. And then once he has those two maxes, then he looks at them between those two maxes, which one is the largest, and then that's the answer. Within each one of these scenarios, he does a similar processing where what he does is he looks at the max. So for example, here in the first three, he's figured out what the maximum loot is for those first three houses. And then for the next step, he takes a look at he compares the previous max, which is the maximum of the first two houses, plus the house immediately after. So here I've indicated that as X, right? So he takes the previous max plus X and compares that with max, and sees which one is bigger. If previous max plus X is bigger, then that's the new max. If previous max plus X is less than max, which is the 3, then he keeps that as the max. Okay, so using that algorithm, he goes on and keeps iterating until he gets to the end of the array. And then once he gets to the end, then whatever is the max, that's the max for that round. Okay, so that's kind of the algorithm that he took. And so let's take a look at his code here. You can see in the first function, max loot, that's where he divides it up into two arrays. One that starts from the beginning but skips the last house, and then the second one starts from the first house and goes all the way to the last house. And then for each one of those, he calls find max loot. So find max loot basically just implements that algorithm that we just talked about in the diagrams. And then, so he finds the maximum for the first scenario, the maximum for the second scenario, and then whichever is the max between those two, that's what he returns. So yeah, within find max loot, you'll see that he actually uses the flag skip first num. So skip first num would either remove the first element or removes the last element, depending on whether that flag is true or false. And then it would go on and go into this iterator, the for loop. And then there he has two variables, the max, which in my diagram showed you, like, say, the 3, and then the previous max. So he compares the current max to the previous max plus the next house. And then it just keeps going on in that iterator like that. Yeah, so that's what he did. It works. It gives the right answer. Arthur also submitted a similar algorithm. The code is completely different, but the thinking was also the same. Yeah, so what are your thoughts on this, Ronald?
Yeah, so this is actually one of when I first approached this problem. This was one of the ways that this is one of my answers as well, but we'll also go through the most optimal solution in the end. But this is definitely a valid answer. My only thing to note is that because you're doing this for loop twice, there's ways to optimize this a little bit more. But I would say if you were going to be putting this into maybe a bigger program, this is perfectly acceptable, because there might be some cases where you want to just handle the more generic case, and this certainly allows you to do that without optimizing it too much to the point where it's very specific. I guess what I mean is, if you're looking to find the max loot within an array, maybe the function needs to be a little more reusable in a different variety of contexts. So I think if you're as we always talk about in these kind of critiques, you're always kind of looking for that balance between optimization and kind of readable code, right? So I think, depending on the situation, this is perfectly acceptable. And there's not too much to say about it other than, I guess, for this particular exercise, we can go a bit further.
Yeah. Okay. Great comments. I do have a couple critiques. This is nothing to do with the algorithm, but this is just a coding best practices critique. So the first one, when I looked at the line here where it says, where you're making, Oscar's making a copy of the array. So I was thinking, when I first read this, why are we making a copy of the array? Because we already have the array up here. So why are we making a new prices one here? And then I realized the reason he's doing that is because inside this function, he actually modifies the array, right? Because here there's remove. So depending on what the value is of skip first num, the array is actually modified. So I think in terms of best practices, I would suggest maybe instead of modifying the array, so you can pass the same array here, but maybe you can pass in some sort of index here. So passing a parameter into find max loop that says where you want it to start, the start and the end index. So it's still traversing the same array, but then you pass in the indices of the start and end of where you want this find max loop to start and end. That saves you the copying of the array, and it saves you modifying the array. Typically, it's when I look at this as an input parameter, an array as an input parameter, I don't normally expect when I call a method that it'll modify that array, and so that's a side effect, right? I don't want to have a side effect that when I call this, after I make this call, my array is now different, right? So I don't want to be a side effect. So best practices, let's try not to do that, right? Try not to modify the array. If you absolutely have to modify the array inside find max loop, then inside this function you can make a copy in here, and then you modify that copy, so the original array is not modified. I guess that's one of the idiosyncrasies, I guess, of some of these C-type languages, right? Like Java, C++, C, where input parameters could actually be modified. Yeah, so that was the main critique that I had from just a coding perspective. So we mentioned earlier Arthur's code is completely different. So Arthur doesn't do that. He doesn't modify the array, but he makes he actually makes a copy inside the second function. But my critique with Arthur is that your variable names could be better. So Arthur, if you're listening, your variable names could be better. I mean, you did provide comments in your code as to what the variable is supposed to be, but that's good that you're commenting on what this variable is supposed to be. But if you made the variable name itself descriptive, then you wouldn't need as much comments on what that variable is supposed to be. And also, it's easier for the reader, right? Because as I see that variable, that name itself describes what it does. Okay, so I'm getting off my soapbox now. Okay, let's look at submission 2. So this submission 2, I put it in here. It's kind of interesting. This is submitted by Eric. It's not his whole code. It's just a little snippet. It's a very similar algorithm to Oscar's, but whereas Oscar worked from the start to the end, Eric's goes from the end to the start. So if you look at his for loops here, he starts from the end of the array and works backwards. But he also split it into two, one where he skips the first house and one where he skips the last house. So it's a very similar algorithm. Yeah. So those are all the submissions we wanted to look at. Ronald, did you have anything else here before we go on to look at your optimal solution?
No, I mean, starting from the back is definitely valid, but I guess I'm just more curious if there was any reason why Eric chose to start from the back. I mean, it's valid, but yeah, if you're listening, please feel free to leave a comment in this section below.
Yeah, that's right. I'm wondering too. That's a good thing. That's one thing I like about looking through this code, the code submissions from the different students, is I see what they're doing, and I wonder why did they do it this way. So yeah, please leave a comment. We'd love to hear from you as to what was your thinking. Okay, so let's take a look at the optimal solution. So Ronald, maybe you can walk us through this.
Yeah. So as I kind of mentioned a little bit earlier. All the submissions, most of them, we were traversing the array twice. And actually, we can do a little bit better because since we're already walking the array at least once, and we know the problem set in that you just need to find the like I kind of mentioned in the challenge video, what you want to do is consider the cases without the constraint of the houses being in a circle. So if you just look at the houses and you're traversing through to find the max value, at the very end, all you need to do is to consider the case with the first house and also the case without the first house. So with the first house and without the last house, and then without the last house, without the first house and with the last house. Okay, so because we know that problem constraint, we can actually just have the pointer as you're traversing through the array, walk through it once, but as you're going through it, you have two different pointers kind of operating simultaneously, one ahead of the other. So in my for loop there, you can see that I started one of them one ahead of the other, and they also subsequently stop. One of them stops one before the other one. So because compare one starts from the beginning, it will know to stop one before the last element, and subsequently because the compare two starts one ahead, it will stop when it hits the end of the array. So I use the I as the kind of central pointer, but then I use two pointers to keep track of where I am. And as I'm walking through the houses, I can get both amounts at the same time.
Awesome, yeah.
And so at the very end, once I finish traversing through it, I just need to get the max value between the two kind of scenarios, the two pointers.
That's awesome. That's the first time I'm looking at this code too, Ronald. But yeah, I like it. It works really well because for both of these counters iterate through the for loop the exact number of times, the same number of times. So your index is just one index is ahead of the other, but you can do both simultaneously in one iteration because it's the same amount of number of iterations. Mm-hmm. That's cool, yeah.
And then the other thing that I do want to point out is the append. You can see the amounts one dot append compare one. The amounts that I'm appending is actually the max values up to that point in time. So I'm storing the maximum robber value up to that point in time. So that would allow me to kind of in the scenario where we had the 10, 2, 2, 10, 2, 2, that allows me to kind of look back in time to see what is the maximum value if instead of the kind of naive solution of skipping every other house.
Yeah. Okay. Awesome. Yeah, I think I can't remember. One of the other students actually did something similar to where they're appending an array with their running maximum. We didn't show their code because unfortunately that algorithm doesn't work for a bunch of other cases. But they used a similar approach where they were appending to an array as you did here.
Yeah. And I mean even between like Wilbur who's not on this critique today, but his solution was a little bit different in fact too, but it works the same in that it gets the right answer. But for him, he chose to kind of dynamically compare the values as it keeps going. So he doesn't store It doesn't store it in an array like I did it. So definitely this problem had a lot of different approaches, and there wasn't one right approach necessarily.
Awesome. We should say that maybe some of the students haven't seen Python before, and so they would look really weird to them. But we encourage you to try to understand what this is doing anyway, because it's quite readable. You should be able to understand what's happening, even though you've never coded or never seen Python. You should be able to go through this and understand what's happening here, because a lot of the computer science fundamentals, a lot of the software fundamentals are the same, right? We have ifs, we have for loops, we have elses. It's just the syntax is different, but the fundamentals are still the same.
Yeah. And the reason why actually I did this in Python is actually because I'm trying to get better at Python. I mean, I'm picking up Python, I've worked with other languages, but it's definitely a learning experience, and you're going to continue learning. So if you want to challenge yourself, you can always redo this problem in Python and learn the syntax, right? And I hope you can also notice that it's really a syntax thing. Like, I think the biggest difference, at least in this code snippet, between the Java and the Python is how Python does the for loops. You can see like for I in range, and then it goes to length nums minus 1. So what that's saying is for I, so same as in Java, int I, and then it does a range. So range is from 2 to the maximum length of the number array minus 1. So the syntax is a little bit different, but it's quite, once you understand that, then it's quite easy to understand like the for loops is iterating from 2 to length minus 1.
Okay. Awesome. Great. So those are the submissions that we wanted to go over today. A few people said that they were hard. They in fact, a couple said, I thought you said this is going to be easy. So they felt that they were tricked. Yeah, actually, I was surprised too. I mean, I wouldn't say this one was easy, but definitely compared to the problem before with the kind of step counting, the approach was a little bit easier. But I think I was kind of discussing this with Wilbur. I guess the challenge with this problem was that there was no kind of naive solution. Because if you did the naive solution with the even and odds, for example, you're going to get the wrong answer. So I think that was the challenge. But well, I mean, we're going to kind of continue introducing new problems. I mean, this week it might have been a bit hard, but it's not a static target. And as you keep getting better and practicing these problems, hopefully you can go back and try this problem again in 2 months or something like that, and see that it might be easier for you at that point. Yeah, that's right. And as we've said before, just give it a try. Even if you end up not getting a solution, not getting the right answer, the good thing is that you tried, because the effort in itself in doing actually adds a lot into your experience and helps you in getting more familiar with coding.
Yeah, and actually, I mean, if you didn't get the right answer, we kind of gave you the solution now. So I mean, even if you watch this video and then you kind of close the video and then you try it yourself now, I mean, I think there's still value in solving it now that you kind of have the answer. I mean, I find that to be helpful sometimes, even when I'm tackling the hard problems on LeetCode or HackerRank. Just even if I looked at the answer and then I close it and then I try to do it myself, it's not, I mean, I know the approach, but then I still need to write the algorithm, right? So there's still value, I find, in trying it now, even though we kind of gave you the answer.
Yeah. Awesome. Okay, great. So if you found this video useful, please give us a like, comment on in this video. If you have any thoughts or questions, or if you thought that there's something, if you disagreed with some of the things that we said, please give us a comment. Otherwise, we'll see you in the next video. We'll have another challenge coming up soon in another video. Thank you, Ronald.
Yep.
See you. Talk to you soon. Bye-bye.
Bye-bye.